Hello. Hello, dear students. You are able to see the content that whatever shared Jivita, Bharti,
Yes, ma'am. Able to see.
Aishwarya, Lakshmi answering. Very good girl. And one more thing is, have you received your IA marks, all of you?
Yes, ma'am.
Okay, any clarifications you need from that? You have any doubts or any discrepancies regarding your second IA marks? Like, ma'am, I got less marks, I got more marks, like that. Any other issues related to your second IA marks? So please share your information with me, because how can I know that? I think all of you got the marks, right?
Yes, ma'am.
Adya, Shita, Diksha, Jivita, Lavanya, Apurva, Vishwaralakshmi is only answering. What about others? Preeti, what about other students? Aditya Singh,
Yes, ma'am, I got less marks.
Arti,
Yes, ma'am.
got any issues related to your IM? Huh?
No, ma'am.
Huh? No, no issues. You are
No, ma'am.
satisfied with the marks, or you got
Yes,
less
ma'am.
marks, or what you
No,
have
No,
got
ma'am, not satisfied.
correct marks?
I'm
You have to
satisfied with my
tell.
marks, ma'am.
You got less. If you
No,
got
ma'am.
more,
Yes,
keep it with you. If got less, ask me, so that
yes,
you
ma'am,
can
I got
improve
less
your
marks.
percentage. Bhanu Pratap, Bhanu Pratap, Jayashree, Jivita,
Yes,
Arshita.
ma'am.
ಏನಮ್ಮ ಸ್ಯಾಟಿಸ್ಫೈಡ್ ಮಾರ್ಕ್ಸ್ ಎಲ್ಲ ಏನಾದ್ರು ಡಿಸ್ಕ್ರಿಪ್ ಇಶ್ಯೂಸ್ ಇದೆಯಾ?
ಏನು
No
ಇಲ್ಲ
issues,
ಮ್ಯಾಮ್.
ma'am.
ಏನು ಇಲ್ಲ, ಸ್ಯಾಟಿಸ್ಫೈಡ್ ಮಾರ್ಕ್ಸ್ ಎಲ್ಲರಿಗೂನು?
ಎಸ್
Yes,
ಮ್ಯಾಮ್.
ma'am.
ಜೋರಾಗಿ ಹೇಳ್ಬೇಕು, ಅದೇನೋ
ಮ್ಯಾಮ್.
ಒಳಗಡೆನೆ ಹೋಗ್ತಾ ಇದೆ, ಕೆಳಗಡೆನೆ ಗಂಟ್ಲಿಂದ ಕೆಳಗೆ ಹೋಗ್ತಾ ಇದೆ ವಾಯ್ಸು. ಜಯಶ್ರೀ,
Ma'am.
ಹ್ಮ್, ಏನಪ್ಪಾ ಮಾರ್ಕ್ಸ್ ಎಲ್ಲ ಸ್ಯಾಟಿಸ್ಫೈಡಾ?
Yes, ma'am. Yes, ma'am. No issues, ma'am.
ಜೀವಿತಾ, ಲಾವಣ್ಯ, ನಾಡಿಯಾ, ದೀಕ್ಷಾ,
ಸ್ಯಾಟಿಸ್ಫೈಡ್ ಮ್ಯಾಮ್.
ಸ್ಯಾಟಿಸ್ಫೈಡ್. ಕಡಿಮೆ ಅನ್ಸಿಲ್ವಾ ನಿಮ್ಗೆ?
ನೋ ಮ್ಯಾಮ್. Oh my God, less marks, ma'am.
ಏನಪ್ಪಾ ಜೀವಿತಾ?
Got less. No, ma'am. Apurva, ma'am.
ಅಪೂರ್ವ, ಏನಮ್ಮ?
I got less marks, ma'am. 24.
20?
4, ma'am.
ವೈ? You are written all. You
Yes,
attempted all the
ma'am.
questions, Apurva?
Yes, ma'am.
Okay.
Ma'am, I also got less marks, ma'am.
Aditya Singh, how many marks you got, Aditya?
22, ma'am.
20?
2.
ಜೋರಾಗಿ ಹೇಳು.
Mm,
Aditya, speak loudly.
yes, ma'am. Yes, ma'am, 22, ma'am.
22. Why? I think you are
Ma'am,
written no less answers.
ma'am, I
Theory,
wrote all.
theory paper you are supposed to write very good and quality quantity answer, right? Then only you will get full marks in theory subjects. You know that it's not like mathematics or programming subject. If you are going to write quality of answers, then you will get full marks. If you write some stories, then you will not get the marks. That is what theory paper expects the answers from the students. Okay, no problem. I'll look into that. Okay, next test you do well, because fourth and fifth modules are very easy chapters, right? And you do well, right? I'll improve your marks in the third internals, right? Still you have one more internals. Be serious. I think if college starts, that will be in the offline mode only, right? So you be prepared well. So in today's class, I am going to discuss the revision part of the module 5. That is, what is the questions and how to answer. If it is 4 marks, how much you need to write? If it carries 6 marks, how much you need to write, like that, right? So here first we have one question bank which I already shared with you people, and it is also available in the MS Teams, right? See now, give a brief note on Arduino UNO. Module 5 is a content of Arduino board and Raspberry Pi, right? So about the concept of Arduino board and why Arduino is you are using, what are its advantages, and what are the how we are going to install the Arduino software, right? Then the next is how we are going to um, now give a brief note on Arduino UNO. You have to write about the Arduino board. The Arduino UNO is a microcontroller based 80 mega 328. Okay, it has 14 digit input output pins, of which 6 can be used as PWM outputs, 6 analog inputs, a 16 megahertz ceramic resonator, a USB connection, a power jack, an ICSP header, and a reset button. Okay, you have to write something about the Arduino board. Okay, I think you people are familiar with the Arduino board. Okay, then it contains everything needed to support the microcontroller. Microcontroller is going to work as a brain of your Arduino board, right? And it's simply connected to your computer with a USB cable, or power it with a AC to DC adapter. Because it is an electronic circuit, it requires minimum 3 volts and maximum 5 volts. Okay, you have to convert your AC voltage alternate current into the direct current, which is of 5, maximum of 5 volts. Okay, to get it started. Okay, battery to get started. The UNO differs from all the preceding boards in that it does not use the USB to serial driver chip. Instead, it features the 80 mega 6U2 up to version R2 driver chip. Instead, it feature as this one, right? So if you don't write this and all, it's okay, no problem, right? So this pin out added SDA and SCL pin that need near to the A free to other this, and placed near the reset pin. Okay, and you have to tell about all those things. Okay, and since it carries only 4 marks, don't write much information. How many marks is allocated, only that much you need to write. In future, shields will be compatible both with a board that uses the AVR, which operate with 5 volts, and with Arduino Duo that operate with 3.3 volts. As I told, minimum voltage will be 3.3 volts and maximum is 5 volts. The second one is not connected pin, that is reserved for the future purpose. There is a stronger reset circuit. Okay, and we use a 80 mega 16U to replace the 8U2. UNO means one in Italian and is named to mark the upcoming release of the Arduino 1.0. The UNO and version 1.0 will be the reference versions of Arduino moving forward. The UNO is the latest in series of USB Arduino board and the reference model for the Arduino platform for comparison with the previous versions. So next is with a neat diagram explain Raspberry Pi board. Okay, that is also only 4 marks. So just you put a skeleton of that Raspberry Pi. Okay, see there. So you can see SD card, USB, right, LEDs. Okay, and then you have power cable, CPU, GPIs. Okay, so skeleton of the Raspberry Pi board you need to write. And various components of Raspberry Pi board are the CPU, that is the ARM CPU or GPU. This is a Broadcom, that is a system on a chip that is made up of an ARM central processing unit and a video core 4 graphics processing unit, that we call it as a GPU. And CPU handles all the computations that make a computer work, taking input, doing calculations and producing output. and GPU handles graphics output. Okay, so you have to write about the components labeling part, whatever the skeleton of your Raspberry Pi board contains labels. You need to explain all the labels of that Raspberry Pi board. Okay, the other one is a GPIO, that is a general purpose input output connection point that will allow the real hardware hobbyist and opportunity to thinker. Okay, then RCA. Okay, an RCA jack allows the connection of analog TVs and other similar output devices. And audio out, that is the jack of audio we call it. Okay, where your audio is going to be played. This is a standard 3.55 millimeter jack for a connection of audio output devices such as headphones or speakers. There is no audio in, only the output whatever we are getting, it is going to be played, and that we can easily hear with our headphone or the speakers. We have one jack called as audio output where we can connect our audio devices to that particular place. Okay, then LEDs. So LED stands for light emitting diodes for all of your indicator light needs, right? So next is a USB. This is a common connection port for peripheral devices of all types, including your mouse. Peripheral devices means all your input and output devices are called as a peripheral devices. Okay, which is going to include the mouse and keyboard. Model as 1 and model B as 2. Okay, so you can use a USB hub to expand the number of ports or plug your mouse into your keyboard if it has its own USB port. Okay, so USB port is there, that is used to connect your all your input and output devices like mouse and keyboard to operate your Arduino board. And it can use a USB hub to expand the number of ports or plug your mouse into your keyboard. It has its own USB port. Okay, next is high definition multimedia interface, that is HDMI we call it. This connector allows you to hook up a high definition television. Okay, then okay, so or other compatible devices we using an the high definition multimedia interface cable. And there is a jack. This is a 5-volt micro USB power connection into which you can plug in your compatible power supply. Okay, that is what. So what are the label you are going to write it on a skeleton of your Raspberry Pi board, right? So you need to explain each and every label for what purpose those ports are used, or those SD card slot. For example, this is a full-sized SD card slot. An SD card with an operating system installed is required for booting the device. They are available for purchase from the manufacturers, but you can also download an OS and save it to the card yourself if you have a Linux machine and the wherewithal. Okay, then Ethernet. There is another label called as a Ethernet, right? This connector allows for wired network access and is only available on the Model B. With neat diagram, explain the wireless temperature monitoring system using the Raspberry Pi. Okay, so you need to explain the wireless temperature monitoring system using Raspberry Pi. See here, so you can see there temperature sensor, gas sensor, right, and pressure sensor, photoelectric sensor, right, and MEMS. Okay, then you have Raspberry Pi board which is going to have the interface with the all these sensors, and all these sensors are connected to are going to send the information to the Raspberry Pi, right, board. And see there, your Raspberry Pi board contains the LAN which is connected into the network, because whatever the information the sensors are going to produce, that has been transferred to your Raspberry Pi port for further processing. Okay, Next is the components required for the implementation of digital temperature sensor. E is 18B20, okay, and resistor with a 4.7 kilo ohms, breadboard, jumper wires, connecting wires, and Raspberry Pi kit. The resistor it utilizes a pull-up for the data line. It ensures that one data line is a described logic level and limits the interference from mechanical sound if the pin is left floating. Jumper wires is used for interfacing Raspberry and sensors. Okay, and we are going to connect all the general purpose input output ground pin and the pi to the negative side of the breadboard and link this 3.3 volt general purpose input output on the pi to the positive side on the breadboard. Next step is to insert a DS, that is a temperature sensor, into the breadboard. Connect this with the ground to the negative side on the breadboard and V pin 3, that is a voltage, the 5 volts to the positive side of the breadboard. Next step is to place a ARM controller of 4.7 kilo ohm resistor to temperature sensor and other end to the positive side of the breadboard. Finally, link your temperature sensor to GPIO alongside a jumper wire. Okay. So next is about the smart city. One question they have asked about the detailed smart city architecture. Okay. Then with a case study, explain the smart and connected city using the Raspberry Pi. You can write any case study like a traffic system you can write, okay, or street light system you can write, or smart hospital management you can write, okay, or home energy automation you can write. Any test cases and smart parking system also you can write. Any test you use, that is a case study. You have to take one case study and you have to explain how smart and connected cities using the So you are going to study, you take one example, okay, any example of case study you can take, okay, which I explained. So I think 4 or 5 case studies I explained: smart parking system, traffic system, street light system, and hospital smart hospital management system, and one more is a smart home energy automation, right? So any of the example you can take as a case study and you can explain how smart and connected cities using the Raspberry Pi. Okay. Now see, IoT enabled smart city causes a span multiple areas, from contributing to the healthier environment and improving the traffic to enhance the public safety and optimizing street lighting. Below, we provide an overview of the most popular use cases that are already implemented in smart cities across the globe. Okay. Smart cities ensure that their citizens get from point A to point B as safety and efficiently as possible. To achieve this, municipalities turn the IoT development and implement smart traffic solutions. Okay, these smart traffic solutions use different types of sensors as well as the fetch GPS data from the driver's smartphones to determine the number, location, and the speed of the vehicles. At the same time, your smart traffic lights connected to the cloud management platform allow monitoring green light timings, automatically alter the lights based on the current traffic situation to prevent the congestion. That is it, to control the traffic, right? Additionally, using the historical data, smart solutions for traffic management can predict where the traffic could be go and take measures to prevent a potential congestion. Because say for example, how can we predict, or with a historical data, how we are going to predict on this day or particular time you have a lot of traffic congestion over some area, right? That is based on the information that, say for example, in any metropolitan cities or capital cities, the office opening times and office close times, right? And afternoon lunch time, everything we are going to count. And not only we are going to look into the timings of that thing, even also we are going to keep in track that, or taking the historical data, what will be the approximate traffic to that particular time, right? So peak hours, we can say that, okay, there will be too much congestion. Based on that historical data and the working day or not working day, right, we are going to predict that the traffic will be this much at this time and this particular time, like. Okay, so additionally, using this historical data, we are going to take some preventive measures to manage the traffic by predicting where the traffic could go and take measure to prevent the potential congestion. For example, if you take one of the most traffic affected cities in the world is Los Angeles, has implemented a smart traffic solution to control the traffic flow. Road surface sensors and closed service television cameras and send real-time updates about the traffic flow to central traffic management platform. The platform analyzes the data and notifies the platform users of congestion and traffic signal malfunctions via desktop user apps. Additionally, the city is deploying a network of smart controllers to automatically make second by second traffic lights adjustment, reacting to changing the traffic conditions in real time. Okay, this is what you need to write. You take any case study, no matter, right? You can take a smart city architecture, or that is a case study as a smart parking system, a traffic control system in the city, or the home energy automation, or smart hospital management system, or smart parking system as a case study, and how these devices are going to be connected with the smart uh, sensors. Okay, then how those sensors are going to send the information to the customers, right? You need to explain all these things. That is about the questions which are you are expecting for the module 5. So other question paper, these are all the solved question papers actually. So other question paper, let me know that module 5 is now they may ask the question, explain the smart city security architecture, right? And write a short note on IoT challenges and backhaul technologies. So IoT challenges are nothing but that is backhaul technologies. Manufacturers of network switching equipment use the term mean getting data to the network backbone, which is similar to using the state of communication, because it carries only 4 marks. 2 marks for IoT challenges and other 2 marks for your backhaul technologies, right? For example, assign the user term to describe how its max 2000 switch can be used to interconnect data from a backhaul T1 line to which mobile and remote office users are connected to an internet service provider and the backbone of the internet. Backhauling may sometimes be used to mean the use of back channel on a bidirectional communication line. Okay. So next is they may ask questions like say 1 second. Explain the following with respect to Arduino programming. Structure of the Arduino programming, right? Functions which we are going to, variables, flow control statements, constraints and data type. With respect to your Arduino programming, it carries only 8 marks. So structure of the Arduino program can be divided into 3 main parts. That is the structure, values, variables and constants and functions. So we will learn about the Arduino software program step by step and how we can write a program without any syntax or compilation error. Let us start with the structure of your Arduino programming. It contains two functions. One is called as a setup function. The other one is called as a loop function. Okay, and setup function is written only once. It is used only for initialization purpose of initializing all the variables. Okay, and loop function is going to be repeated for loop. The name itself says that that is going to be repeated for so many times. That is a execution part of your the Arduino programming. The purpose of setup function is called when a sketch starts. It uses to initialize the variables, pin modes, start using the libraries, etc. To set up a function will only run once after each power up or reset of the Arduino board. Okay, see input, output, return you will have. Then say while loop. The purpose of this loop is after creating the setup function which initializes all the variables and sets the initial values, the loop function does precisely with its name, suggests and loops consequently, allowing your program to change and respond. Use it to actively control the Arduino board. So input, output, return. A function is declared outside any other function above or below the loop function. We can declare the function in two different ways. The first way is just writing the part of the function called a function prototype above the loop function, which consists of function return type, function name, function argument type. No need to write the argument name. Function prototype must be followed by a semicolon, and it demonstrates the function declaration using the first method. See, int some function int x comma y as a parameter to that function. Okay, function definition will be z initializes to 0 to show that z does not contain any value. Okay, and we are going to store the addition of two numbers x and y into the z. That is z is equal to x plus y. So you can ask one question, ma'am. In our A level programming language, we never used to initialize the third variable, which is going to store x and y 0. No, ma'am. Why we are going to store here z is equal to 0? This is because since we are going to use a microcontroller program, so where microcontroller is having some registers and that data may get manipulated with the some of the, it may take some junk values in the registers. Okay, that is the reason why we are going to take the z value as a 0. Void setup, okay, statement, some group of statements we are going to initialize, and wired loop we are going to call the some value and we are going to print the result in that loop itself. Then come to the variables. As we already know that all the programming language will have the variables where we are going to input the value. Okay, variables that are declared inside the function or block or local variables, they can be used only by the statements that are inside that function or block of code. Local variables are not known to the function outside their own. Following is the example of using the local variable. Say, so this a, z is a local variable declaration. Okay, and x is equal to 0, y is equal to 0, actual initialization. and we are initializing that is also is equal to 10. Then flow control statements, we have if statement, if else statement, and if else ladder are the nested if else statements we have. So if statement takes an expression in parentheses and a statement or a block of statements. If the expression is true, then the statement or block statements gets executed. Otherwise, these statements are skipped. Okay. If else statement can be followed by an optional else statement which executes when the expression is false. Okay. If else can be followed by a optional else if. Okay. We call it as a useful for test various conditions using the single if else and the if statement. That is about you need to write about the flow control statement, and you have a switch statement, right, which is going to have multiple choices, right? So if you are going to use a if else, nested if else or ladder else if, then it is going to give a lot of confusions with respect to the if else expressions are begin and end, and what statements are belong to the if else if it is too deep in nesting, right? So that is the reason why we are going to use a switch statement. That is, it will have multiple choices, that is called as a multiple case statements. So depending upon the switch choice, right, it is going to execute a particular case. Okay. See, similar to the if statement, switch case controls the flow of the programs by allowing the programmer to specify different codes that should be executed in various conditions. Okay. So conditional operator, the conditional operator we call it as a question mark colon, is the only ternary operator in C. And as I told that your Arduino programming is going to follow the syntax and the logic of your C programming concept. So okay. So here also we are going to use a ternary operator, that is question mark and colon as a ternary operator for the conditional operator, right? So when you come to the data types, okay, like C language, even the data types in C refers to the extensive system used for declaration of variables or functions or different types. The type of the variable determines how much space it occupies in the storage and how bit patterns is interpreted. Okay. So it will have them say void, long, boolean, unsigned long character, short integer, unsigned character, float, byte, double, int, array, unsigned int, signed int, character, word and string object. Okay. You can write enough because it carries 8 marks. So if you write this much, it's more than enough. Only you specify the data types. Then come to the constants. As I told, const is a keyword. You stands for the constant. It is a variable qualifier that modifies the behavior of the variable, making a variable read only. This means that how many times you are going to execute the program, all the time that program constant value remains the same. It does not change its value. Okay. But the value cannot be changed. You will get a compile error if you try to assign a value to constant variable. Constants defined with a const keyword obey the rules of the variable scoping that govern other variables. This and the pitfalls of using as defined makes the most keyword superior method for defining the constant and is preferred to using the define. So that is a const float pi is equal to 3.14 say, and instead of everywhere we are going to initialize value 3.14, wherever the pi value is required I can just specify the name pi, so that replaces the constant value 3.14. Okay. So next is so write a Python program on a Raspberry Pi to blink an LED. See now that is a program you can write. So turns LED on for 1 second, then off for 1 second repeatedly. Okay. So we are going to use a setup pin mode 2, where we are going to initialize the digital pin 13 as a output, and pin mode 2 comma output. Okay. That is we are going to initialize a setup function, and when you come to the loop, okay, so turn the LED high voltage level, okay. So see, given 1000 means 1 second, it is in milliseconds. Oh, so 1000 seconds will be is equal to 1000 milliseconds will be is equal to 1 second, right? So again digital write low, so I is a the 5 volts and low is a 0 volt, okay. So what he is asking, blinking of a LED. So 1 second it switch off, 1 second it is going to glow with a high voltage. That is why see digital write 2 comma low, this turn the LED off by making the voltage is equal to 0. Low means it is 0, high means it is 5 volts. Again 1 minute delay after 1 second, sorry, 1 second delay, it's not 1 minute, sorry, it's 1 second delay. Again it is in the loop, right? So it's keep on displaying the LED for every 1 second, okay. So that is what you are going to write the Raspberry Pi blink on an LED, okay. If you have any doubts, you please ask me with related to your academics, okay, related to your subject clarification, okay, question and answers, and any doubts related to your subject or any questions, you bring it to my notice if which one I not discussed, so that you people can understand very well. If you solve question papers, at least you will get an idea. See, IoT, discuss IoT challenges. This is a module 2. About all modules question and answers are there in this scanner, so which I already shared with you people. You can go through that and you can prepare well for your forthcoming examinations. Again module 5, see, they explain the features of Arduino with regard to the IoT network. It carries 8 marks, okay. So an Arduino Uno is a microcontroller board based on this all IOT, right? Operating voltage, microcontroller input voltage, okay. So you can write, you need to write all about the Arduino board, okay. What are the models of Raspberry Pi? There are 6 different models of Raspberry Pi. You can write one by one, and what are their advantages, why, and you can write what is a temperature sensor. It is a device typically thermocouple of body provides from temperature measurement through an electrical signal. Thermocouple is made from dissimilar metals that generate electrical voltage in direct proportion to changes in temperature, okay. Then explain how IoT can be used with the consumer appliances. So consumer benefits personally and professionally from the optimization and data analysis of IoT. IoT technology behaves like a team of personal assistants, advisors and security. It enhances the way we live, work and play. Okay. So IoT takes the places of full staff. Okay. Butler, chef, nanny, gardener, repairman, security guard. So next is about the explain the IoT applications for smart cities. You can write a more efficient water supply, okay, an innovative solution to the traffic congestion, more reliable public transportation, energy efficient buildings, okay, then improved public safety. These are the different applications of for smart cities. Explain the IoT applications for smart cities. Approximately 70% of the world population expected to live in the cities by 2050 according to the Gartner. This rapid urban growth is already placing a considerable strain on the existing infrastructure, and with more people making the move to urban living, it is only going on get worse in the coming years. To accommodate this new demand on cities, municipalities around the globe are turning to the internet, okay, of things innovations finance the so enhance the services, reduces the cost, and improve the communications and interactions. Though the potential is there for IoT, okay, and applications for smart cities. Another efficient water supply is that is you will get all these if you are going to have a smarter cities, will get all these facilities. Okay, that is what is about the what I can say that okay, smart city applications. Okay, these only Raspberry Pi Smart City. Three questions you can expect in Module 5. One is the Raspberry about Raspberry Pi, its board, its features, right, and its programming, any programming using Python. Second is Smart City architecture. Okay. Third is Arduino UNO. It is related to the Arduino UNO. Okay, that's it. Okay, if these are the three topics which I covered in the module 5, and you can expect only those questions from the Arduino. Okay, so that is what I can say. I'll conclude my class. If you have any doubts, I will tell you. If you are not studied, don't worry. Try to solve the question papers so that you will get full marks. Okay, so that you will prepare well for the exam also. Right? Bhanu Pratap. Okay, I will wind up the class. Thank you, one and all. Have a nice day.